Application of heat transfer. Reducing thermal energy transfer in building. To keep a building warm in winter and cool in summer, we need to minimize unwanted heat transfer by controlling conduction, convection, and radiation. 1. Insulation reduces conduction. Use thermal insulation in walls, roofs, and floors to slow down heat flow. Ceiling of rooms is covered by insulating materials, false ceiling. Materials like foam, fiberglass, and wool trap air and reduce conduction. 2. Double-glazed windows reduce conduction and radiation. These windows have two glass layers with air or gas in between, which reduces heat transfer. They also reduce radiant heat from sunlight entering or leaving. 3. Sealing gaps reduces convection. Use weather strips, rubber seals, or caulking to seal gaps in doors and windows. This stops air leaks, preventing warm air from escaping in winter or hot air from entering in summer. 4. Reflective surfaces and curtains reduce radiation. Use reflective foils or coatings on roofs and windows to bounce sunlight away. Thick curtains or blinds help block heat loss during cold nights. 2. Application of transfer of heat maintaining liquid temperature. How a thermoflask maintains liquid temperature. A thermoflask is designed to minimize heat transfer through three key methods. 1. Vacuum insulation stops conduction and convection. The flask has double walls with a vacuum, empty space, between them. Since there are no particles in a vacuum, conduction and convection cannot occur, so heat doesn't easily enter or leave. 2. Reflective coating reduces radiation. The inner surfaces of the walls are coated with a shiny, reflective material, like silver. This reflects heat radiation back into the liquid, if it's hot, or away from it, if it's cold, reducing heat loss or gain by radiation. 3. Tight lid prevents air exchange. A well-sealed lid prevents hot air from escaping or cold air from entering, stopping heat transfer through convection at the opening. The cork is an insulator. It also reduces transfer of heat through conduction. 3. Application of heat transfer. Heating room by convection. A heater, like a gas heater or radiator, warms the air near it. Warm air rises because it becomes lighter, moving to the top of the room. Cooler air sinks to the bottom, gets heated, and rises again. This creates a convection current that circulates warm air around the room, gradually making the whole room warmer. 4. Application of heat transfer. Mechanism of a household hot water system, heating the water. Inside the water heater, geyser. The heating element warms the water at the bottom of the tank. Convection starts. As water heats up, it becomes less dense and rises to the top of the tank. The cooler, denser water at the top sinks down to take its place. Natural circulation. This rising of hot water and sinking of cool water creates a natural convection current inside the tank. This circulation helps distribute heat evenly throughout the water. Hot water supply. When a tap is opened, the hot water from the top of the tank flows out through pipes. At the same time, cold water enters the bottom, continuing the convection process. 5. Application of heat transfer. Cooking and kitchen pan using conduction, convection and radiation. 1. Conduction, heat through solids. When the pan sits on a stove, heat transfers from the stove to the metal base of the pan. Then, heat moves through the metal pan to the food touching the surface. This is direct heat transfer through solid materials. 2. Convection, heat through fluids, liquids or gases. As the food, especially liquid like soup or oil, heats up, the warmer parts rise and cooler parts sink. This movement forms a convection current, which helps heat the entire contents evenly. 3. Radiation, heat through waves. The pan and stove emit infrared radiation, which adds to heating the food. Though less than conduction and convection in a pan, infrared heat from glowing coils or gas flames also helps cook the food. So, in summary, conduction heats the pan and food in contact. Convection circulates heat through liquids. Radiation adds heat via infrared waves from the stove or pan surface. 6. Application of heat transfer. Measuring temperature with infrared thermometers. An infrared thermometer detects heat radiation from a surface and converts it into a temperature reading. It's fast, contactless, and ideal for measuring from a distance. Precautions when using an infrared thermometer. 1. Keep lens clean. Make sure the sensor or lens is clean and undamaged, as dirt or scratches can affect accuracy. 2. Avoid measuring through glass or plastic. Do not measure through transparent materials, as they can distort infrared readings. Thank you for watching. Please like, subscribe and share with others.